everyone. In this video, we're going to talk about how to write some recursive rules for other sequences besides arithmetic and geometric. So we have a previous video on how to write a recursive rule for an arithmetic and a geometric sequence, so you can check that out in the top right-hand corner right now. For this video, we're going to look at three other sequences that are sequences, but they're not arithmetic, they don't have a common difference, and they're not geometric, they don't have a common ratio, but they're still a sequence. So we should be able to write an equation to find the nth term, or whatever term we want in the sequence, okay? So let's look at this first sequence. We have 1, 1, 2, 3, 5, and 8. So hopefully we can recognize the pattern here, and maybe you've seen a sequence like this before. We take these two terms and we add them together to give us the next term, right? So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8, so on and so forth, right? So we could write the next couple of terms here. So 5 plus 8 would be 13, 8 plus 13 would be 21, and 13 plus 21 would be 34, okay? So now, what is our rule? What is happening here? Well, we are adding the two previous terms to get the next term, right? So really the third term is key here, because the third term is where we can start to build our sequence, right? We have to know what the first two terms are. That has to be given to us. So when we write our recursive rule, we're going to say a sub 1 equals 1, a sub 2 equals 1, right? That has to be given to us. We have to know what the first two terms are, or we can't add the two previous terms to get the third term, right? Okay, so now we're going to say a sub n is equal to, now we're going to say a sub n minus 2 plus a sub n minus 1. So let's talk about what that means, okay? So a sub n minus 2. Well, n is the position of the term, right? So if I want to find, like we said, let's say we want to find the fourth term in the sequence, right? So here we know it's 3, okay? So I would plug 4 in here. So that means I would have a sub 4 minus 2 plus a sub 4 minus 1. Well, this would be a sub 2 plus a sub 3. So that means add the second term and the third term together. So the second term and the third term gives me my fourth term, okay? So this right here would be my recursive rule for this sequence, okay? So like I said, hopefully you've seen a sequence like this before, because this is actually referred to as the Fibonacci sequence, right? Which is really cool. It's naturally occurring in a lot of different ways in nature, so pretty cool sequence there, okay? Let's look at the next one. We have 1, 1, 0, negative 1, negative 1, 0, 1, and 1. So let's kind of try and figure out what's going on here, okay? Well, right off the bat, we say, okay, how about 1 minus 1, right? Because that's 0, okay? But then we should have 1 minus 0. That means that term, the fourth term, should be 1, and it's negative 1. So we know that's not what is happening, okay? There's still some subtraction going on, though. So with these two terms, how am I getting negative 1? Well, we are subtracting, but we're subtracting 0 minus 1, right? So we still need the two previous terms. So that has to be given to us again. So we're going to say a sub 1 equals 1, a sub 2 equals 1, and now we're going to write our recursive rule, a sub n equals. Okay, now this time, the order matters, right? The order that we are subtracting matters. So we want to subtract the next closest term with the term that's two positions away, right? Or the second previous term. So we're going to say a sub n minus 1 minus a sub n minus 2, okay? So for example, if we want to find the fourth term, so we'll circle that. The fourth term is negative 1. So that would be like a sub 4 minus 1 minus a sub 4 minus 2. So a sub 3 minus a sub 2. So that would be the third term, which is 0, minus the second term, which is 1. So 0 minus 1, and we get negative 1. Okay, so that one there, since we are subtracting, the order definitely matters. So we're going to write it in that order. Okay. All right, and the last one, 4, 3, 1, 2, negative 1, 3, and negative 4. Okay, so let's think we're getting smaller here, so maybe subtraction, right? So 4 minus 3 gives me 1. 3 minus 1 gives me 2. 1 minus 2 gives me negative 1. 2 minus negative 1 would become 2 plus 1, which is 3. So we know what our sequence is here, okay? All right, so let's add the next three terms. I know we didn't do that on the previous one. We'll go back and do it in just a minute, okay? So 1 minus 3 would be negative 4. 3 minus negative 4 would give us 7. Negative 4 minus 7 would be negative 11. And then 7 minus negative 11 would be 18. Okay, so there's our next three terms. Once again, we have to know what the first two terms are. So a sub 1 equals 4 and a sub 2 equals 3. And now we can write our recursive rule. Okay, so now this one is almost exactly like the one we just did, but we are now subtracting the term 2 previous minus the 1 previous. So we want to say a sub n minus 2 minus a sub n minus 1. Okay. All right, so for this one, let's say we want to find, what is this? The 1, 2, 3, 4, 5, the sixth term, right? So that would be like a sub 6 minus 2 minus a sub 6 minus 1. So a sub 4 minus a sub 5. So the fourth term minus the fifth term, right? So fourth term minus the fifth term. And that would be 2 minus negative 1, which is what we did to get 3, okay? All right, so that's how we write recursive rules for other sequences, specifically like the first example we did, the Fibonacci sequence, which is a very popular sequence in the world around us. So before we go, let's add the next three terms to the second sequence that we did, right? So this was 1 minus 1 gave me 0, 0 minus 1, negative 1 minus 0, negative 1 minus negative 1, 0 minus negative 1, 1 minus 0. So this one's going to be 1 minus 1, 0 minus 1, 0 minus 1, and then negative 1 minus 0, okay?